Assalamu alaikum students. So today we will be looking at some other projection methods in this lecture number 4. And as we talked about in the previous lecture, we saw parallel projection, orthographic projection and multi-view projection. So today we will just look at perspective projection, oblique projection, that is part of a parallel projection, and axonometric projection, that is another type of orthographic projection. So let's have a look at that, and just going to these projections before explaining them, we will look at the purpose, that why are we looking at these type of projections, and why not just multi-view, parallel and orthographic projections are enough to communicate our drawing. So let's have a look at the usage of these projections first. So the usage is in Pictorial Sketch, and Pictorial Sketch is the one in which a 3D object uh, is represented on a 2D sheet of paper by orienting the object so you can see its width, height and depth in a single view. Uh, Before that we were talking about multi-views, and in multi-views we only had 2 dimensions in one view. Like if this is your front view, so you only had width and height. But in pictorial sketches or in pictorial view, we orient the object as such that we see the width, height and depth in a single view. Please note that these type of pictorial sketches cannot be used for manufacturing purposes. They are only used to present your design idea to someone, to communicate engineering design to a non-engineers, to non-technical persons, and they are used to show how parts fit together in an assembly. So these are the purposes for which we use pictorial sketches. And again, these are 3D objects that are represented on a 2D sheet of paper, such as their width, height and depth are shown in a single view. So let's look at one example. Just as you are looking at this diagram, as you can see, this is a pictorial sketch, and in this pictorial sketch you can see the width of your object, you can see the depth of your object, you can also look at the height of your object. But you cannot use this drawing for manufacturing purposes. You can just communicate it to someone to represent your idea, and you can communicate this to a non-technical person, or you can use this to assemble it somewhere in the machine. So again, it cannot be used for manufacturing purpose, but it can be used to communicate an idea or to communicate to a non-technical person. Just as we talked about, these type of drawings are also used for assembling a part. Just as you can see, this is an assembly. This is an assembly, and this diagram below shows that how this assembly is being made. So these are also pictorial sketches. As you can see, you are shown that how each part fits another part and how they are going to be assembled. So as we talked about, there are also pictorial sketches are also used to assemble objects. So they are not used for manufacturing purpose, but they can be used to show that how a certain part can be assembled from different components. So projection methods we talked about, and we also saw this mapping, and we saw that we have 2 projection methods. One was parallel, the other was perspective, and we discussed the parallel projection technique in depth in the previous lecture. Then we saw that parallel projection also had 2 types. One was orthographic, the other was oblique. We discussed the orthographic type, and then we had another 2 types of orthographic projection, and that was axonometric and multi-view projections. So today we are going to discuss perspective projections, oblique projections and axonometric projections. And as we discussed, these projections, these perspective, oblique and axonometric projections are used to draw pictorial drawings. They are used to draw pictorial drawings. They are used to draw 3D objects on a 2D plane, such as their 3 dimensions, the height, width and depth are shown on a single 2D plane or a piece of a paper. As you remember, you were given exercises for your in your manual lab, in which you were given a task of drawing views, 2D views of a 3D model. That 3D model was also drawn on a single page on a 2D plane. So that represented perspective view or oblique view or axonometric view, whichever one that was. But again, these type of projections, perspective projection, oblique projection, and axonometric projections are used to draw the pictorial views of a 3D object on a 2D plane. So, perspective projection, as we already discussed this briefly in the previous lecture, this projection mimics what the human eye sees. Whatever we experience through our vision in our daily life, that is a perspective projection that is being made in our brain and then in our vision center, and we see a different object with the help of our eyes. But that is again a perspective projection inside a brain, inside our brain. So in perspective projection, the object is positioned at a finite distance and viewed from a single point, a single station point. And perspective projection, as you remember, the lines of sight are not parallel. As you can see, they actually converge at a single point. So that's why the true size of an object cannot be drawn. So images formed are always shorter or larger than the actual dimension of the object and are somewhat difficult to create. So let's look at some types of perspective projection first. Again, as we talked about, the lines of sight actually converge at a single point. So if this is our object, if this right here is our object, and if we draw this object on a plane that is beyond this, is plane behind this, is placed behind this object, then this object will be drawn larger in size than the actual size of this object. And if we place a plane in front of this object, then we will get a view of this one side of this object that will be shorter than the actual object. So again, perspective projection, in perspective projection, the lines of sight converge at a single point. So in perspective projection, we have again three types, and that is 1, 2, and 3 point perspective projection. And the one you are seeing right now is 1 point perspective projection. In this 1 point perspective projection, the lines of sight converge at a single point. There is a single convergence point, and this plane right here, will be parallel to the plane of projection. So this is 1 point perspective projection. Then there is 2 point perspective projection. In 2 point perspective projection, we have two convergence points. And this edge right here, is parallel to the projection plane. Then we have 3 point perspective projection in which we have 3 convergence points. And right in this type of perspective projection, we have nor an edge nor a plane that is parallel to a projection plane. So in this type, we have 3 convergence points, but no edge or no plane is parallel to the projection plane in this type of perspective projection. So again, we have the 1, 2, and 3 point perspective projection, and again they can be used to draw the pictorial view of any object. So let's have a look at some images and comprehend that how they are 1, 2, or 3 point perspective projections. As you can see that here you can see that the picture is converging at a single point, right here, it is converging at a single point right here, and the plane, this overall plane is parallel to the plane of projection. So this is 1 point. This is an example of 1 point perspective projection. Then in 2 point perspective projection, we saw that the image is converging at 2 points. So there is one convergence point is right here, the other convergence point is right here, and here right here there is an edge, this edge right here, that is parallel to the plane of projection. Then there is the 3-point perspective projection, in which we have 3 convergence points. We have 3 convergence points, and there is nor an edge nor a plane that is parallel to the plane of projection. And as you can see, this is again a pictorial view. You can see the height, the depth, the width of a certain entity in a picture. But again, this picture is drawn on a 2D plane, and this represents 3 dimensions. So this is a pictorial view. So what are the disadvantages of perspective projection? And perspective projection again is not used by engineers to manufacture parts, because it is difficult to create, and it does not reveal the exact shape and size. So again, as we already discussed, it cannot be used to manufacture different parts that are actually required. For that purpose, the engineering drawing is used. For what purpose engineering drawing is used? It is used to manufacture different parts. But we cannot use the perspective projection or the oblique projections or the axonometric projections for manufacturing parts, but they can be used to represent an idea by drawing a pictorial view of a certain object. So the second part is oblique projection, and as you can remember, the oblique projection is a type of parallel projection. It is a type of parallel projection technique. So oblique projection, in oblique projection, the object and the plane are aligned as such that when the lines originate from these corners, these lines will be parallel to each other, but they will not make a 90-degree angle with this plane of projection. So if we are looking at this, so the lines are extended as such, the object is actually moved a little to this side so that the lines remain parallel to each other, but they do not form a 90-degree angle with the plane of projection. So if we draw the object now, we will actually get the 3 dimensions. We will actually get the height, width and depth of this object. So again, a pictorial view is drawn. So for that purposes, we can also use oblique projection. And again, oblique projection is a part of a parallel projection technique. And in this technique, what we do, we slide our object a bit so that the lines of sight and the plane of projection do not make a 90-degree angle with each other. So again, oblique projection is the basis for oblique drawings and sketching, and again they can be used to draw pictorial views. It is again a form of a parallel projection, and projectors are parallel to each other, as we already discussed. Projectors are not perpendicular to the plane of projection, and one face of an object is parallel to the plane of projection. One face, like you can see this object right here. This is the orthographic view. This is the orthographic view of this object, where you are seeing different oblique projections of this object. But in orthographic projection, we are only 2 dimensions are visible, the width and the height. But in oblique projection, we can actually see the width, the height and the depth. And in orthographic projection, the angle between the lines of sight and the plane of projection is 90 degrees. But if we move away from a 90-degree angle, if we move the object as such that the lines of sight and the plane of projection does not make an angle of 90 degree, then we will be able to see these 3 dimensions on a 2D plane. So for different angles, you will get different pictorial views, but at the end, this plane will always remain parallel to the plane of projection. This plane right here, as you can see, this plane will always remain parallel to the plane of projection. So let's look at this again. This is our oblique view and oblique drawing angles. Let's discuss them. So if the drawing angle is 30 degree, and if a drawing angle is 45 degree, or if the drawing angle is 60 degree, if it means that the lines of sight and the plane of projection are making an angle of 45, 60 and 30 degree. So what will be the characteristics of our oblique views? So let's look at them. From this we get another 2 types of oblique drawing. One is Cavalier, and the second is Cabinet. So in Cavalier, the angle that the lines of sight in the plane of projection make is actually 45 degrees, and for that what we get, we actually get the full length of our depth of our object. We get full scale. This depth will be drawn to full scale in this type of Cavalier oblique drawing. And in cabinet drawing, other than 45 degree, if any other angle is selected, then this depth right here, this dimension right here will not be drawn to full scale. It will not be drawn to full scale. It will either be enlarged or it will be shortened, as we saw in the previous slide. So these are the two types of Cavalier and cabinet oblique drawings. This will always be drawn to half scale if we move the theta other than 45 degree. These are the two examples. This is the example of Cavalier projection, in which the depth dimension is drawn to full scale because the angle right here is the theta is 45 degrees. But here the depth dimension is drawn to half scale because the angle is not equal to 45 degrees. So these are the two types, the cabinet and the Cavalier projections. This is again the type of oblique projection that is represented in a single image, and as you can see, the lines of sight are parallel. The lines of sight in parallel. This plane of the object is parallel to this projection plane, and the lines of sight and the angle between the plane of projection is not 90 degree, but it is a theta that is other than 90 degrees. Then we have the third part of projections, and this third part is axonometric projection. And axonometric projection is a type of orthographic projection. It is the type of orthographic projections. So in this type of projection, what we do, we actually tilt our object as such that we get all our dimensions, the height dimensions, the width dimensions, and the depth dimensions on a single 2D plane. And in this type of projection, as you can see, it is a type of orthographic projection. So the lines of sight and the plane of projection will make an angle that will be equal to 90 degrees. But again, the object will be tilted. It will be tilted. So if we place a plane in front of this object and we actually protrude some lines from these corners, then we will get an object of a 2D view or 2D pictorial view in which all the three dimensions will be visible: the height dimension, the width dimension, and the depth dimension. And based on these three dimensions, what these three dimensions do, they actually form a corner. They actually form a corner, and they actually form angles. These three axes, actually these are three axes that are formed. By doing this exercise, we get actually three axes: this axis, and this axis. And these axes makes different type of angles with each other, and from these angles we actually classify different types of axonometric projections. And you will also be familiar with a few type of axonometric projection from your AutoCAD course, like isometric projections. You will be familiar with that. So now let's look what isometric projection. So if we take this object and we take these three axes, we take this axis, and we take this axis, and we change the angles between these three axes, so we get different type of axonometric projections. So again, if we build the object as such that these three axes are visible, and we look at this corner, we get a single corner because these three edges right here make a single corner. So if we look at this like this, and then we get different type of axonometric projections. So axonometric, they can also be called the axonometric axes. These three can also be called the axonometric axis. So axonometric axes are axes that meet to form a corner. They meet to form a corner of the object nearer to the observer. So this corner will be nearer to the observer, and these axes join at a single point, at a single corner. So now let's use these three edges to identify different type of axonometric projection. So the first one is isometric, the second one is diametric, and the third one is trimetric. So you will be familiar with the isometric type of axonometric projection from your AutoCAD course. These are the three axes that we talked about, the three axonometric axes, and these axes make an angle of A, B, C. So if these angles, all these angles are equal, then that type of axonometric projection will be called the isometric projection. Then there is diametric axonometric projection, and in diametric axonometric projections only two angles will be equal and the third will be unequal, and in trimetric axonometric projection only none of the angles will be equal. So in isometric all the angles are equal, and in diametric only two angles are equal, and in trimetric none of the angles are equal between the axonometric axes. So that's how we identify different type of axonometric, the three types of axonometric projections. These are the axonometric axes again, and you can see that how these axonometric axes form different angles between each other, and when these angles are equal they are called isometric. When two angles are equal they are called diametric, and when three angles are not, they are unequal to each other, they are called trimetric axonometric projection. Then there are some other types by position of isometric axes, that how we position them, and isometric axes can be arbitrarily positioned to create different views of a single object. Like we can actually take different, we can actually select different axes. We can select different axes as our axonometric axis, and we can create different isometric or trimetric or diametric views for our axonometric projection. Just like in regular isometric, what we do, we actually look from the top to a certain object. We look from the top to a certain object, and the edges we see, the edges that are visible, and the corner that is nearer to us, and the edges that define, the three edges that define this particular corner, we take those three edges as our axonometric axes, and we then define the angle between these three axonometric axes, and then we actually identify them as isometric, diametric, or trimetric. So now this is regular isometric. So by regular isometric means that all the three angles are equal to each other. Then there is reverse axis axonometric isometric, and in reverse axis isometric we are actually looking from the bottom to the top of an object. So from here what we see, the corner that is nearer to us and the three edges that is forming this one corner, we then identify these three edges as our axonometric axes, and then we create three angles between these axes, and as it is reverse axis isometric, so the three angles in this case will be equal. Then this is the long axis isometric, and in long axis isometric we actually look from the right or left of an object, and then we identify our three axonometric axes, and then we identify the angles between them to get our isometric, diametric, or trimetric axonometric view. So these are another three types based on how we look at an object. How we look, if you are looking at it from the top, that is regular isometric. If we are looking from the bottom, that is reverse of isometric. If we are looking from the sides, that is long axis isometric view. Then in this figure again, the whole axonometric projection is explained, and as we saw, axonometric projection is a part of orthographic projection. And in orthographic projection, what we defined it as the line of sight, the lines of sight and the plane of projection actually make a 90-degree angle between each other, and the what we actually get a corner, and that corner is formed by three axes. We define them as axonometric axes, and then we define angles between these three axonometric axes, and what we do, we actually then see what those angles are, and if those angles are equal, we define them as isometric. If two angles are equal, then we define them as diametric. If none of them are equal, then we define them as trimetric. So this is how the axonometric projection work, and we form this type of view by tilting our object. We actually tilt our object to get the three main dimensions, the height, width and depth, on a single plane, and thus we form a pictorial view. We form a pictorial view of our 3D object. Then again, this is another type of orthographic projection with which you are familiar. And in this case, again, this is also the parallel projection, but it is also orthographic, because the lines of sight and the plane of projection make a 90-degree angle with each other. And this is a projection technique with which you are familiar, and you have already practiced this a lot in your engineering drawing lab.